Right, so for number 35, I'm going to distribute the sine. And remember, cosecant is 1 over sine. Phi is the angle here. So let me distribute it first. So it's going to be sine phi times 1 over sine phi, that's cosecant, minus sine squared phi. So right here, sine over sine cancels, and you're left with 1 minus sine squared phi, and that equals cosine squared phi. Alright, so for number 38, I'm going to convert both numerator and denominator into sines, in terms of sines cosines. So the numerator is 1 over cosine theta, and the denominator is 1 over sine theta. So this is 1 over cosine theta times, remember when you divide by a fraction, you are multiplying by its reciprocal. So sine theta over 1. And so sine over cosine gives you tangent. Alright, so for 41, I'm going to use the cofunction identity that says that sine of pi over 2 minus x is equal to cosine x. And cosecant x is 1 over sine x. And so cosine over sine is cotangent x. Alright, for 44, cotangent squared x plus 1, that's one of your Pythagorean identities. And that equals cosecant squared x. And the reciprocal of cosecant x is sine x, so this becomes sine squared x. Alright, so the numerator is difference of squares, so I'm going to go ahead and factor that. So that's cosine x minus 2, and cosine x plus 2 over cosine x minus 2. Okay, so this factor is common in the numerator and denominator, so that cancels to 1. So you're left with cosine x plus 2. Alright, so number 50 is a quadratic, because remember, sine to the 4th x is like sine squared squared. So it is a quadratic, and I'm going to factor it like this. Let me just put this here. 1 minus sine squared x times 1 minus sine squared x. And when you distribute this, you get the original back. Okay, so I factored it. I can write it as 1 minus sine squared x squared, because there are 2 of those. And 1 minus sine squared x is cosine squared x squared. And then to get rid of the parentheses, it looks like this. Alright, 53 is a 4-term expression, so I'm going to factor by grouping. So I'm going to group these two together and these two together, and the first pair has cosecant squared x in common, so I factor that out of both of them. Oops, not squared, sorry. Cosecant x minus 1. And then in the second pair, I can factor out, because see, I have to make this match this factor, and right now it's the opposite, right? So I'm going to factor out a negative 1, and that leaves me with, oops, I'm always switching these, leaves me with cosecant x minus 1. So now you factor out this factor out of both of them, both terms. So you have cosecant x minus 1, and the remaining factor is cosecant squared x minus 1. Okay, now here, this is the difference of squares, or you could think of it also as Pythagorean identity. And so that would be cosecant squared x minus 1. This is cotangent squared x. And then this one, there's really nothing else you can do to this one. You just write it down, and that would be the simplified form. Alright, so we're going to multiply the binomial, 1 plus tangent x. And so remember, it's 1 plus 2 tangent x plus tangent squared x. Now if you can't go from this step to the one I just did, remember it's the same thing as, let me change the color, 1 plus tangent x and 1 plus tangent x, and then just do distributive property. This times this times this, and then this times this times this, and you'll get this. Okay? Now, they're not next to each other, but this one and this one form a Pythagorean identity. 1 plus tangent squared x is secant squared x. So I'm going to substitute that. So the final answer would be secant squared x plus 2 tangent x. And that's all you can do to simplify. For number 59, we're adding two fractions with different denominators. So the common denominator is 1 plus cosine x times 1 minus cosine x. So we're going to multiply the first fraction by 1 minus cosine x. Just write it separately first to show all the steps, and then plus 1 times the second fraction gets multiplied by 1 plus cosine x. And both numerator denominator. Okay, there you fit. Alright, so distribute the 1. So in the numerator, now that we have the same denominator, right, we can combine the two. So I'm going to do that in this next step. Distribute the 1, so I get 1 minus cosine x. Distribute the other one, I get plus 1 plus cosine x. All over, now I'm going to go ahead and multiply these two. So that gives me 1 minus cosine squared x. Now the ones you add together, and the cosines in the numerator are gone, right? They cancel out, it's 0. So we're left with 2 over, well, 1 minus cosine x is sine squared x. And when sine squared x is in the denominator, you could change that by, when you move it to the top, it becomes cosecant squared x, because those are reciprocals of each other. And that's your final answer right there. Alright, for 62, the first thing I'm going to do is change the tangent to sine over cosine. That way I have two fractions, because I'm going to be adding them together. So I'll put cosine x. So the least common denominator, the LCD, is this times this, right? So that's what I'm going to just write one big fraction, and I'm going to put this as my common denominator for both of them, both fractions. So the first fraction, I'm going to take sine x, multiply it by 1 plus sine x, because that's what I need, that's what I need to multiply top and bottom on the first fraction. On the second fraction, take cosine x, I need to multiply the second fraction by cosine x, so that I get this, so that I can have, the denominator on the same denominator on both fractions. So, oops, I gotta do this. Distribute the sign in the first one, so that in the first term, so that's sine x plus sine x squared, and then multiply cosines. I'm gonna leave the denominator undistributed. I'm gonna leave it as two separate factors like this, because I'm starting to see that, as you go through these problems, you start to pick up on patterns, right? So I'm looking here, and I notice that these two right here add up to 1. And I see a 1 right here. And then I see a sign, and I see a sign. So I'm like, oh, that's going to cancel, right? So I'm going to do sine x plus 1 over cosine x, 1 plus sine x equals, and so this and this cancels, and you're left with 1 over cosine x, which is secant x. So the goal on 65, the instructions say to rewrite it so that you have no fraction. So to do that, let me start by changing this to sine x over cosine x, the definition of tangent. And when you multiply, or when you divide by a fraction, you're multiplying by its reciprocal. So cosine over sine, like that. And so I see sine over sine is 1, it cancels, and you're left with cosine x. And that's your answer. For 75 and 77, it's asking you to graph the expression to determine which of the 6 trig functions you end up with. Like, do you end up with sine, cosine, tangent, cosecant, secant, or cotangent? Which of the 6 do you end up with? So I encourage you, before you do the algebraic work, that you go to Desmos if you don't have a graphing calculator, or use your own graphing calculator. Input this expression and see what you get. Okay? So do that first. So you'll notice that when you plug this in into a graphing calculator, this becomes cosecant x. Okay? So now we're going to prove it or show it algebraically. We're verifying it algebraically. So I'm gonna write cosine x. This is cosine x over sine x plus sine x. So the numerator and the first term is cosine squared x over sine x plus sine x. That's over 1, right? Okay, so I'm going to get a common denominator of sine x, so that gives me cosine squared x. So the first fraction already has a sine x, right? But the second one doesn't. So sine x times sine x is sine squared x. And look at the numerator. It's a Pythagorean identity, and that's equal to 1. And so when you change it to its reciprocal function, it's cosecant, and that's exactly what we saw on the graphing calculator. Okay, this is a true or false question. So cosecant and sine are reciprocals of each other, so when you multiply them together, you get 1. So this is true for all theta, for all angle theta. So number 109, the functions are reciprocal of each other, cosine and secant. They are. The problem here is that the angles are not the same. So if the angles are not the same, they're not going to cancel each other out. For example, if you have cosine of 30 degrees times the secant of 180 degrees, let's say, secant of 180 degrees is negative 1, and cosine of 30 degrees is radical 3 over 2. This does not equal 1. So this is false because we found a counterexample that doesn't make it work. And generally speaking, for this to be true, for this statement to be true on 109, these angles have to be the same.